Keep doing. All right, guys. So we're going to keep solving kind of some of the problems we were doing yesterday, but this time there's some special solutions that we're going to come across, some special cases. Solving variables with both sides. To solve, we simplified both sides. Now we did some of these yesterday. We did most of these yesterday. Went through this one. Now, special solutions of linear equations. Linear equations do not always have one solution. An equation that is true for all variables identified as infinitely many, and if it's not true, it has no solution. And we'll get into specifics of what that is here in a minute. So when we look at these here, we're going to deal with special types of solutions. So our first one here, we have 3 parentheses, 5x plus 2 equals 15x. So if we're solving for x, what is the first thing we need to do for this here? What is the first thing we need to do to solve this one here for x? 3 times 5x and 3 times 2. So we're going to have 3 times our 5x plus 3 times 2 equals 15x. Well, 3 times 5x, well, 3 times 5 is? So we have 15x. 3 times 2 gives me? 6. Any questions on any of this so far? We good with this here? Now what do we need to do? We need to get the x's on the same side, yes? So how can we move the variables, the 15x from one side to the other? We would subtract it. We would subtract 15x from both sides. Well, 15x minus 15x is, so I have 6 equals 15x minus 15x is, what do we have here? 6 equals 0. 6 equals 0. Is this a true statement? Will 0 ever equal 6? No, this is a false statement, isn't it? So if we solve one of these and we get a false statement, this is no solution. Because what that's saying, there is no value of x that will make this true. There's no value of x that I could plug in to that original statement, 3 times 5x plus 2 equals 15x, and get a true value. It will not work. I won't be able to have both sides equal.
So, can there be an x equals 0?
Mm-hmm.
But there can't be a 0 equal 100.
No, because this here, there's no way that works, right? So the one we dealt with yesterday, or the other day, yeah, there was one yesterday that x equals 0. I'm trying to remember which one it was. Oh, you're good. So let's see here. 0, because that'd be 5, 8, so it's not that one. It's not that one. 0, 56 is 14. So it's not that one. That was -2. I think it might have been the last one we did. So I believe it's this one here, because it works out if this is the one. So 8 times 0 is 0, yes? Well, 0 plus 12 is just 12, correct? And it works out here, that would be 3, so we get -9. We kind of good with this here? Well, here, 0 minus 3 is -3. So it works. So here the value of x is 0. It is a number. But what we're saying with this one here is no matter what value of x I plug in, I will never get the same thing on both sides. So there's no number that works. It won't work at all. Does that make sense? Because really, so I have 15x and 15x. So if I plug 1 in, this will always be 6 greater than this side over here. So no matter what I do, it will not work. Okay? Does that make sense? Yes? So if it works out that we get 0 equals a number, or what it said at the beginning, a false statement in that little box at the very top. So an equation that is not true for any value of the variable has no solution because it doesn't work. Now let's look at this one here. So again, the first thing we're going to have to do is use the distributive property, yes? Because we got a number outside of parentheses. So we're going to have -2 times 4y plus 1 times -2 equals -8y minus 2. So -2 times 4 is what? 1 times -2 is -2. I see what you're saying. Yes, we're going to have some zeros show up, yes? Because if I add, because I'm going to have to add 8y to both sides, yes? To get them on the same side. So if I add 8y to both sides, well, -8y plus 8y, 0. 0 on both sides, yes? What am I left with? -2 equals, -2 will never equal -2, right? It will, won't it? Will there ever be a case where -2 won't equal -2? Well, -2 is always -2, isn't it? Is there any way it couldn't be? Well, then it wouldn't be -2, would it? No, I mean, there's no way -2 will not equal -2, correct? Or let's just say I added 2 to both sides. So I'm just moving it from one side to the other. Well, it just tells me what? 0 is equal to 0. 0 is always 0, isn't it? Is this a true statement? So what that tells me is this is all real numbers. All real numbers. I know it's hard to read numbers. But what that means is that any value of x that you want to plug in will work. Any value of x will work for this here. This is all real numbers. So I'm going to erase all this here. So let's give me a number. Doesn't matter what. So if we work this out, and I'll do this by hand, 4 times 6 is 24 plus 1 gives me 25. -8 times 6 is 48. Well, -2 times 25 is -50. 48 minus 2 is. Doesn't matter what the number is, it will always work. Because when we get an all real solution, it means any number I plug in will work for this. So 6 worked. I'm going to try 0. Well, 4 times 0 is, plus 1 is just 1, yes? 8 times 0 is 1 times -2 times 1 is. So no matter what number I pick, it will always work. It will always work. Let's really put that to the test. Let's say 1/4. I'll tell you right now that 4 times 1/4 is just 1. 8 times 1/4 will be -2. 1 plus 1 is? -2 minus 2 is? This here, that's why they say all real numbers. Because no matter what number I plug in, it will always work. Questions on this here? Yes, there is a shorter way to write all real numbers. All real numbers is what they'll sometimes write it as, but this is the set of all real numbers. So this is the real number system. Questions on this here? So really there are two cases we're looking at. One, 0 is equal to a number, yes? Or really, we have, it may not even be 0 equals a number. It might be 7 equals 4. Will 7 ever equal to 4? No, it'd be nice if my $4 automatically became $7. That'd be great, wouldn't it? It just increased like that, I didn't have to do anything, but no. Because if we get a false statement, then it's no solution. That's one of our cases that we could see. Our second one is that it's true statement, so it's all real numbers. And then our third case is kind of what we dealt with yesterday, where we have a solution, a number. X equals 0, x equals 5, x equals 1/4, where it's one number. Okay? So these are the three kind of cases we can come across. There's one of these three here. And if you're wondering, could we have kind of sets of numbers? Not with equations. Where we couldn't have x is greater than 2 for any value for that. Because that wouldn't be equations, that would be inequalities, and we'll cover that later. Okay? So let's do another one of these here. So what would we need to do to solve this? Well, the first thing I need to do is to multiply through by 4. Well, 4 times 3d is 4 times -1 is now what do? Not just 12, but 12d. Well, these here cancel, don't they? What about over here? So what do I have? -4 equals, so this here is we're done. That's all we have to do there. Questions on this here? We good with this here? Yes? No? Maybe? Do we need to see another example one of these? Because I don't mind doing more examples. We good? Yes? No? Good? Yes? Or do you want to see another one? Because I don't mind doing these. I can do these all day. So again, when we want to solve one of these here, we want to get the w's on one side. We want to get everything else on the other. Now, before we can start moving stuff from one side to the other, we've got to make sure we have everything combined on either side. So here we have to multiply through by 7. So we're going to have 7 times 3 minus w times 7. Now, we don't have to do anything over here, because the 21 minus 7w is as simplified as it gets. There's no like terms on that side. Because they're all combined, we only have 2 terms. But we do have to do some simplifying on the right side. Okay, 7 times 3 is 7 times -w, or -w times 7 is -7. W. So really the right side, we just repeated it just to keep it on the same line. Is that the same thing on both sides? So most likely what's going to happen?
It's going to be
All real numbers. It's going to be all real numbers. Or infinitely many solutions. So we can add 7W to both sides. And what that'll give us, well, these cancel. These cancel. So 21 equals 21. It works. So we can say all real numbers or infinitely many solutions. Because there's infinite amount of numbers that we can plug in. So we can call it all real numbers or infinitely many solutions. It just depends on how they want to phrase it. Does that make sense? Yes? I have a feeling most of y'all are getting this. I'm starting to bore some people. Yes? I know I'm different because I'll do these all day long.